Good morning students. So previous session we have seen the state table, right? Now today I am going to explain what are sequential circuits, right? From this diagram you can understand that the sequential circuits are considered as interconnection of combinational circuits as well as the flip-flops, right? So sequential circuits are considered as what here? Interconnection of combinational circuit as well as the flip-flops here. Or you can say that, so here this combinational circuits, it is considered as a gates here, right? When they are included with the flip-flop, then the overall circuit or the overall structure is known as what here? Sequential circuits, right? So here you can give the definition as what here? Sequential circuit is nothing but it is an interconnection, right? It is an interconnection of combinational circuits and flip-flops, right? So what you can define here? So sequential circuit is nothing but interconnection of combinational circuit as well as a flip-flop here. And if you check this diagram here, this combinational circuits, they are also considered as what here? Gates here. When multiple gates are interconnected with each other, then it creates what here? Combinational circuits. So this combinational circuits will get the input. If you check here this arrows, it will get the input from the external input, right? And it also takes the input. See here second arrow, this is also input to the combinational circuit. From where it is getting the input? So it gets the input from where? The output of the flip-flop, right? So the combinational circuits will get the input from the external input as well as it takes the input from where? The output of the flip-flop will be given as an input to the combinational circuits. And the combinational circuits will generate the output. So the output is going to be sent to what? External output as well as the output of the combinational circuit is also given as input to the flip-flop, right? So next one is what here? Input and output. So how the combinational circuit is getting input? It is getting the input from the external input as well as it takes the input as what here? The output of the flip-flop will be given as input to the combinational circuits, and the combinational circuits will generate the output. Where it will go? The output will go to the external output as well as it is given as what? Input to the flip-flop, right? And next one is what here? The flip-flop. So what is the use of this flip-flop and what is the use of the gate here, right? So flip-flops are used for store the data. Already we know flip-flops are used for what? Storing a bit of data here. So flip-flop is used for what here? Store the data. And what is the purpose of gates here? Right? The gates are used to specify how, right, as well as when the data has to be stored. That is the roles played by the flip-flop as well as the gates here. Flip-flops are used for what here? They are used for storing the data, and the combinational circuits, that is nothing but what? Gates. So gates will decide. So how and when the data has to be stored within the flip-flop here. And last one we have the output, right? The output of the entire sequential circuit, right? So the sequential circuit, the general output, right? So here I told the output of the combinational circuit. Last point is what? The output of the sequential circuit is a function of what here? Present state of the flip-flop as well as a external input. So next one is what here? The output of sequential circuit. So how we are getting the output of the sequential circuit means, so we are getting as a functions of what? Present state of flip-flop and so external input. So how we are getting the output here? The output is generated with the combination of present state of the flip-flop as well as the external input. And if you find out, if you want to know the next state of flip-flop, right? So again the next state of flip-flop is also identified with the same thing, present state of the flip-flop as well as the external inputs. So these are the points which you have to remember within what here? Sequential circuit, right? Once again I am repeating here, sequential circuit is nothing but interconnection of flip-flops and gates. The gates are nothing but what here? Combinational circuits. When these combinational circuits are interconnected with the flip-flop, the overall structure is known as a sequential circuits here. Now this combinational circuits, from where it is getting the input, right? It gets the input from the external input as well as the output of the flip-flop will be given as an input, and the output generated will go to what here? External output, and it will be given as input to the flip-flop. So what is the use of this flip-flop and combination circuits? Means flip-flops are used for what? Storing the data, and the gates will decide how and when the data is going to be stored here. And next point is what? The output of the sequential circuit, the entire circuit output where it is going to go means, so how it is going to be generated means, it is a function of present state of the flip-flop as well as what here? External input. And next you want to find out flip-flops we have seen. So the next state of the flip-flop, right? So that is also a function of how we are getting the next state of flip-flop means, that is a function of the present state of the flip-flop as well as the external inputs. Right? Next concept here. So how we are going to convert a sequential circuit into state diagram. Right? So how we are going to convert the sequential circuit into state diagram here, right? So they will be provided with this sequential circuit. Now from this sequential circuit you have to generate the state diagram here, right? So how the sequential circuit is given. So if you check here this sequential circuit, right? I told the definition, what did I told sequential circuit? It is an interconnection of combinational circuits. Combinational circuits are nothing but what? Gates here. So this is one combinational circuit. So this one you can take combinational circuit as well as this one, right? Sequential circuit is nothing but what? Combination of or interconnection of combinational circuit and flip-flops, right? So here I am using what here? Two flip-flops. The two flip-flops are what here? D flip-flop, right? So the definition you got here. So how you can say that it is a sequential circuit means, sequential circuit is an interconnection of combinational circuits, gates, right? And flip-flops here. When they are interconnected, then it is going to consider the overall structure is considered as a sequential circuit. So there only I told combinational circuit will get the input from where? External input. So here the external input is nothing but what here? X. And it gets the input from where? The output of the flip-flop. Now if you check here, the output of the flip-flop A is connected to the first AND gate. Now this combination will be what here? AX. Right? And second one if you check here, right? So if you check here, so from where it is getting here? Second flip-flop output, that is B. B is connected, right? The output of the flip-flop as well as what here? The external input X. So now here what you are getting here? BX, right? So combinational circuit will get the input from the external input as well as it will take the input from the output of the flip-flop. So now what you are getting here? Both are performed with what? Which gate here? OR gate. So what you will get here? AX plus BX. So what is the first equation of this D flip-flop here? What you will get here? DA is equal to AX plus BX. Right? Now second one DB, right? So again this is what? Gate. Gate will take the input from external input. External input I have taken X, and it will take one more input from where? The output of the flip-flop. So which one it is taking here? A bar. Now you will get what here? A bar X. Right? Only one AND gate I have used here. So now what will be the DB equation here? DB is equal to A bar X. Right? Now output we got. Right? So output is nothing but what? X. Now Y here output. Now Y is equal to, right? You have to check again here. So this is what here? External input. External input what I have taken here? X bar. Right? X bar. And what is this? Right? This one you are getting from where? B. So B. Bx bar. And now this one if you check X bar. So this input you are taking from where? A. Then it is what here? Ax bar. So both you are performing what here? OR operation. Then you are getting what here? Ax bar plus Bx bar. So Y is equal to what here? Ax bar plus Bx bar. Right? So when you are converting from sequential circuit to the state diagram, so the first step is you have to generate the logical expression using this sequential circuit diagram. So first step I have done. So dA is equal to AX plus BX, dB is equal to A bar X, and Y is equal to AX bar plus BX bar. Next step is I have to generate the state table. Next step is what here? I have to generate the state table. Now what is the state table? Means graph here the specification of sequential circuit. See here I am not giving the definition separately here, right? The specification of sequential circuit is expressed in terms of what here? State table. Right? So the sequential circuits is expressed in terms of what here? State table, which includes 4 sections here. So how many sections it is including here? 4 sections. Under that, first section, it is considered as a present state. First section is what here? Present state. Second one is input. Third one is next state. And fourth one is what here? Output. Right? So first one is present state, second one is input, third one is next state, and fourth one is output here. Now what is this present state? Right? So this present state indicate, right, the state of the flip-flop. We have right 2 flip-flops here, DA and DB. So A and B represents what here? Flip-flops here, DA and DB. So A and B represents the state of the flip-flop at the given time. Right? So present state I told Q of T. Q of T is nothing but what? The output of the flip-flop at the given time. That is nothing but what here? Present state. So here also the same definition. So what is the present state? Is nothing but the state of the flip-flop at the given time here. And second one is what here? External input. Right? Second one is what here? External input. So what is the input? What is the need of this input? Means, so this input will make the transition, right? So that the flip-flop will move from present state to the next state. So for that purpose only we are using what here? Input. And third section is nothing but what here? Next state. So what is the next state? Q of T plus 1 I told. It represents what? The state of the flip-flop after a clock pulse time. That is nothing but what here? Next state, right? So present state is nothing but what? State of the flip-flop at the given time, right? And next state is nothing but what? The state of the flip-flop after the positive transition of 1 clock pulse. That is nothing but the next time. Now which is going to cause the transition? So the transition from present state to the next state. So how it is possible? Means by making use of this state table here. So how it is possible? By making use of this input, that is X. Now I should find out the next state values DA and DB and generate the value of what here? Y. And I should find out how much transition it is moving from present state to the next state here. So which value is going to cause the present state to next state here? That is nothing but the input value. So using these 3 values I have to generate the values here. Now ABC, how many inputs I have? 3 inputs. So how many combinations will get here? 8 combinations. Then in that case, using this ABC values, I have to generate DA, DB as well as the Y. So if you check here, first case, A is 0, B is 0, X is also 0. Now if I am placing here 0 value, DA is equal to 0 into 0 plus 0 into 0. So DA is equal to what? 0. I am placing what here? 0. DB is equal to A bar. A bar is nothing but what? 1 into 0. Why? Because A is 0. A bar is nothing but what? 1. 1 into 0 is again what here? 0. I am placing what? 0. Y. Y is equal to AX bar. A is nothing but 0. X bar is 1. Plus B is nothing but what? 0. X bar is 1. Now again 0 into 1, 0 plus 0 into 1, 0. So what you are getting here? 0. Right? Since first combination all zeros are there, you will getting what? DA, DB, Y as also 0. Now second one if you check here, second combination, right? In case of this second combination, so what is the value? A is 0, B is 0, X is equal to 1. Now here A is 0, X is equal to 1 plus B 0, X is equal to 1. Again 0 into 1, 0 plus 0 into 1 again 0. So what you are getting here? 0. DB is equal to A bar X. A bar is nothing but what? 0 into 1, 1. 1 into X. X value is what here? 1. Now it is what here? 1. A is 0. A bar is nothing but 1. 1 into X value is what here? 1. Then in that case it is what here? 1. So DA value is 0. DB value is 1. Now Y value. A into x bar. A is 0 already. X bar is nothing but what? 0. So 0 into 0 plus B is 0. X bar is also 0. Then what you are getting here? 0. So second case is what? 0, 1, 0. Now third case we will check. So third case is, so directly I will tell here, dA is equal to AX plus BX. AX 0 into 0, 0 plus BX 1 into 0, 0. So what you are getting here? 0. Now dB is equal to A bar X. A bar is what? 1. 1 into 0. What will get here? 0. Now y is equal to AX bar. AX bar 0 plus BX bar. BX bar means what? B. X bar is what? 0. Complement is 1. So you will get what here? 1. Right? Next one is again AX 0 into 1, 0 plus B into X 1. 0 plus 1 is again what here? 1. Right? A bar X. A bar is what? 1. 1 into 1 is 1 again here. Next one, y is equal to AX bar. A is 0. X bar again it is what? 0. 0 plus B is what? 1. X bar is what? 0. So 1 into 0 again what you are getting here? 0. Right? Next one, AX 0 1 into 0, 0 plus BX 0 into 0 is 0. 0 plus 0, 0. Second one, A bar X. A bar is nothing but what? 0. 0 into 0. Again 0. Third one, AX bar. A is what? 1. X bar is what? 1. Plus B into X bar. B is nothing but 0. 0 into 1. Right? So 1 plus 0. Again what you are getting here? 1. Second, next case. A into X. 1 into 1. 1. Plus B into X. 0. So what you are getting here? 1. A bar X. A bar is what? 0. 0 into 1. 0. Right? Next one is AX bar. Next one is what here? AX bar. So AX bar. AX bar is what? 1 into 0. 0 plus BX bar. BX bar. That is 0. Now what you are getting here? 0. Next one is 1, 1, 0. AX. AX 0 plus BX 0. What you are getting? DA 0. A bar X. DB. A bar is what? 0. 0 into 0, 0. Next one is AX bar. AX bar is what? 1 into 1 plus BX bar. B is 1. X bar is nothing but what? 1. Right? So 1 plus 1 or operation you will get what here? 1 only. So you are getting what? 1 here. Next one is AX. 1 into 1 plus BX. 1 into 1. You will get what here? 1. Next A bar X. A bar is what? 0. 0 into X. 0 you will get. Next one is AX bar. 1 into 0 plus BX bar. 0 into 1 again. So what you will get here? 0. Right. So like this I am going to generate what here? State table which includes, right. So which is including what here? The specification of the sequence diagram. Right. So in case of the state table. Now I have to generate what? State diagram. So conversion is what here? Sequential circuit into state diagram here. So now in this case, so how I am going to generate the state diagram, right? So this side we will do here state diagram. Now from the table only you have to draw the state diagram. So how we are going to draw the state diagram, right? So I am taking what here? Two states A and B. So two variables I am taking here, right? 0, 0, right? 0, 1, 1, 1, 1, 0, right? Now in this case, right, you have to check. So the diagram you have to check and you have to write. So what is this state diagram, right? So state diagram is nothing but graphical representation. Any diagram you can say it is considered as what here? Graphical representation. So this state diagram is a graphical representation of the state table, right? So state diagram is considered as what here? Graphical representation of the state table. table, right? Now here this state diagram include again arrows, right? So it is going to include what here? Arrows. So this arrows indicates, right? So the transition from present state to the next state. So if I am using from here to here, again this arrow indicates what here? Transition from present state to the next state. And this arrow is labeled with a value, right? It is labeled with what here? A value, where it is specified with the input / output, right? So when you are moving from present state to the next state, so using which value as an input and which value is generated as an output, so that value you have to include over this arrow. That is considered as a path label. That is considered as what here? Path label. So that path label includes what here? Two values, x and y. X/y. That is nothing but what here? Input / output. So that is the explanation of what here? State diagram. So state diagram is nothing but what? It is a graphical representation of the state table, right? So where it is the arrows represents what here? Transition from present state to the next state. And the transition includes two values, x bar y. X represents input and y represents output here. Now see here, now I will write. So I have written 0, 0. So whenever a value, b value is 0, present state, right? The next state is what? It is also 0, 0. And x and y values are what here? 0, 0. So it is not moving to any state. So 0, 0 to 0, 0 only, right? And x value is what here? 0 and y value is also 0. Now second case if you check, 0, 0 again. AB is what here? 0, 0. And next state is what? 0, 1. Means 0, 0 is moving to what? 0, 1. Right? Present state is 0, 0. So next state value is what here? 0, 1. At that time, what is the value of x and y? So x value is 1 and y value is 0. Then in that case, here I will write label 1/0. Right? Third case. So now here x value AB is 0, 1. Present state is what here? 0, 1. Now from there to which state it is moving here? 0, 0. Where it is moving here? 0, 0. So 0, 1 to it is moving what here? 0, 0. At that time, what is the value of x? X value is 0 and y value is 1. X value is 0 and y value is 1. Right? Reverse. Next case, fourth case. Present state is what? 0, 1. Present state is 0, 1. Now present state to where it is moving? Next state is what? 1, 1. Next state is what here? 1, 1. 0, 1 to 1, 1 it is moving. So that time what is the path label? 0, 1 to 1, 1. X value is what here? 1 and y value is 0. X value is 1 and y value is 0. After that 1, 0. Present state is what here? 1, 0. And next state is what here? 0, 0. So present state is 1, 0 and next state is what here? 0, 0. So that time what is the x value here? 1, 0, 0, 0. X value is 0 and 1. So here x value is 0 and y value is 1. After that 1, 0. Right? Next state is also 1, 0 and x value is 1, y value is 0. So 1, 0. Next state is also 1, 0. X value is 1, y value is 0. And next one is 1, 1. Present state is what here? 1, 1. And next state is what here? 0, 0. Present state is what here? 1, 1. And next state is what here? 0, 0. At that time, what is the value? X value is 0 and y value is 1. Last one is what here? 1, 1. Present state is 1, 1. And next state is what here? 1, 0. So present state is 1, 1. And next state is what here? 1, 0. So again here it will come. Now what is the x value? X value is 1 and y value is 0. Like this, you are going to convert a given sequential circuit into state diagram. So first you have to generate the logical expression. Based on this logical expression, you have to draw the state table. So using this table, you have to give the graphical representation, that is nothing but the state diagram. Thank you.